All right, Algebra 1 folks, thank you for tuning in. Good day. I'm saying good day because I don't know if you're tuning in the morning, the afternoon, the evening. So whatever time of day it is, I hope you're having a good one. Today's video is going to be fairly short. It's going to be very important. What we're going to study in this video is just these data displays. Again, we're going to kind of build off our knowledge from the previous 2 weeks with an emphasis on the shape and the skewness of data. So shape kind of speaks for itself. Skewness is a new word that I'll introduce to you and explain. We're going to dive in right now. Just notice something to point out is in each of these examples, we'll call this example 1, example 2, and then down here, example 3. You're going to see a histogram first, which is, right, this guy right here, a dot plot second, and a box plot third in all three examples. Okay, so something to just for consistency's sake, you're going to see all three of those, and we'll be able to talk about all three on these. Okay, so the first thing we're going to talk about is this shape, right? What shape does the data take on, right? Well, shape, you know what shape means and what we look for when we say something like shape. The first kind of shape that you're going to see amongst data is called symmetric. Okay, I have that starred here. I'm going to circle it here. Just like think about what the word symmetric means, right? Just in general, it means it's the same on both sides, right? So think about letters of the alphabet. Think about if I have the letter A, capital A. Is that symmetric if I cut it down the middle? Yeah, it's the same on the left and the right. What if I have the letter O? Symmetric? Yes, right? One last example, the letter K. Symmetric? This way, it is not, right? It's not the same on the left and the right. So think about what makes something symmetric and what makes something not symmetric. Well, the first type of data display that we see as far as shapes are concerned is this symmetric. Just like symmetric outside of data displays, it just means it's basically the same on the left and the right, okay? So we have this nice like mound shape created here, also known as a bell curve. Kind of has the shape of a bell, like a bell that you would ding at like a hotel or something to get the attention of the worker or whatnot. It's got a nice bell shape, so you'll hear that referred to as a bell shape. Okay, right here in the middle, you see this red line. You should be thinking, okay, we know what that is, right? That's the median, right? The median's always in the very middle. Well, when we have symmetric data, okay, that's also where the mean is, or the average. Okay, so when data is symmetric, right, we have the mean and median are equal. Okay, is one thing that we need to remember. What does it tell us? It tells us that they're equal. The mean and the median are equal. They're right in the middle. The average and the median are about the same, or they are the same, or they're very, very close, right? You might have, I'll give you an example. If the mean is 17, but the median is 16.8, that's really darn close. We're going to go ahead and say that, hey, based on that data, it must be symmetric because those two numbers are so close. Okay, the second thing that we note here is that the data is even on both sides, right? Hence the word symmetric there. So the data is the same on the left as it is on the right. It kind of drops off here to the right as we go towards the maximum, and it kind of drops off here towards the left as we go to the minimum, okay? And you see that same thing here with this dot plot, right? You get that nice bell curve again. How do we know that for a box plot? Well, we have right here is our median and our mean, right? That's always our median point. This 25% piece and this 25% piece are about the exact same size as this and this. And even mathematically, it looks like they are, right? From 10 to 30, the lower 50%, that's a difference of 20. And from 30 to 50, that's also a difference of 20. So it looks like the upper 50% of the data and the lower 50% of the data are exactly the same. So you'll just see that there. What does that mean? There's no outliers, right? There's not that one piece or a couple pieces of data that's pulling our graph shape to the left or to the right. It's just very evenly spread out, dips off to the right, dips off to the left, has a nice peak right here in the middle on all three. Okay, we're going to move on then. So what happens when it is not symmetric? Well, when it's not symmetric, we have these things called the word skewed, right? And you might have heard that used in real life before. I might say something like, hey, that piece of data is really skewing our results. And what that means is it's maybe not making the results evenly distributed or totally representative of that data. So if you were in our class with Mr. Shannon and I this past week, we did that example of the two companies working for company A and company B. And we had at the one company, the boss making a lot more money. His salary was really skewing that data. It was making it seem like those employees at the company made a lot more money than they really did. That data that was skewing that data. It was making it seem like something it maybe wasn't, or pulling data in a certain direction. Okay. So I think that that's not a bad idea to think about. Skewing, when data is skewed, it's pulled in a direction that maybe is not representing the data like we normally would think of it to be represented as. So we have this first example here for skewed. This one is called skewed to the right. Okay, I'll be able to explain that. Okay, so we see this major drop off here to the right. Okay, we have data, what we would call maybe the 60s and 70s, more of your outliers or your data that doesn't fit as well. Same thing here, right? You only have one person answered 60 and one person answered 70 to whatever question was being asked. That doesn't really fit with the rest of the data. A lot of the data is over there to the left. Same thing here. You have 25% here, 25% here, 25% here. And then all the way out here, this 25% is so stretched because you have some sort of outlier up there near 70 or 60, or data that just really doesn't belong with this other 75%. We still have to include it, okay, but it means that it's just really not a part of the rest of that data. What does skewed to the right data tell us? Is there's some sort of outlier or close to it. Okay, so it's either some outlier that's obvious, or it's approaching an outlier and it's really pulling our data a certain direction. Skewed to the right means that the data on the right does not fit the data as well. Okay, so it's really not, again, that example up there, let's imagine that this is the score you got on a test, right? A lot of these students got between a 10 and a 50, and then you have these couple pieces that really don't fit the rest of the class very well. For this case, in a good reason, right? They got better scores, but it really doesn't fit the overall class very well. So that data on the right, over here, and over here, just is not fitting that data as well. Okay, something very, very important, okay, that we talked about, especially with that company 1 versus company 2 problem with the boss, is that you're going to have you're going to have your mean gets pulled higher. Okay, which another word for mean is your average. Your average is being pulled up. In this example, you might have a median right around here, maybe the 25 or so mark, but your mean is going to be here. It's getting pulled up by this data that really doesn't represent it, right? Same thing's happening here. We could find the exact median, right? We could count these dots from least to greatest. Let's just go ahead and do that. We get rid of one, we get rid of the next lowest, the next highest, the next lowest, the next highest, the next lowest, the next highest, next. So we get this guy right here, 30. Again, that was kind of my guess there, 25 to 30 for the median. But you're going to have a higher mean, okay? You're going to have a higher mean because this 60 and 70 is really pulling that data up. So the mean gets pulled higher. So in data that's skewed to the right, we're going to have a mean that is higher than the median, right? Your mean is higher than your median. Your average is higher than the most middle piece of data, okay? Moving on to skewed to the, you can probably already guess what this next one's going to look like. This next one is going to be skewed to the left for the exact opposite reasons as what we just listed up above, right? So now you have some data here that's low, that's really pulling our data down, or it doesn't really fit with the rest of the data over here, right? You have a lot of answers between 30 and 70 here, and even here. And then you have these couple pieces of data on all three of these, this and this, that just do not belong, right? So again, there's some sort of outlier. Okay. Now we're going to say the opposite. If it's skewed to the left, we're going to say that the data on the left does not fit well. Does not fit well. Okay. Just really doesn't fit as well as the other data. So again, kind of bouncing off the ideas that we discussed and skewed to the right, that means that instead of the mean getting pulled higher, we have these low scores, these very low numbers. So now the mean gets pulled lower. Okay, so our mean gets pulled lower there. You're going to have a median that's maybe up in this 45 to 50 range, a median, but the mean, the average gets pulled down because we have these lower data sets. It might be somewhere between maybe 20 and 30 or 30 and 40. Okay, your mean is lower. So then to kind of finalize that, we're going to say that the mean is lower than the median. Okay, and always reference that example of the boss and the employees at the companies. When the boss is making way more money, right, he's pulling the data up. The average is going to be above the median. If you had a situation where somebody was making way less than everybody else, then that number that's way smaller is going to pull the average down. It's going to pull the median down below it's going to pull the mean down below the median. Okay, so some things to consider, some problems that we're allowed to put in front of you is I could put any of these 9 data displays in front of you and just simply ask, what is the shape? Is it symmetric, right? Is it skewed to the right? Or is it skewed to the left? And you should be able to look right at this and say, hey, that one's skewed to the right. There's data up at the right side that's pulling it up. That's not really representative of the data. This one you should be able to say, oh, hey, that's a bell curve, right? We can mention that here. Also looks like a bell curve. Okay, so we could say, hey, that's symmetric. Or, hey, this 50% is about equal to this 50%, so we're going to call that symmetric. Things to consider. I told you I'd keep today's video short. I appreciate you following along, and we will hop into the next lesson shortly whenever you get there. Thank you.